Hello everyone, I'm Prakash Vanga. Overall 13 years of extensive experience specializing in AWS Cloud Engineer and Identity Access Management. Currently serving as an AWS Data Engineer, designing and implementing scalable and secure data pipelines leveraging AWS services. Over the years, I had the opportunity to work across complex enterprise environments helping organizations not only migrate to the cloud but also optimize how they manage data securely, efficiently, and intelligently. Today, I'm truly excited to speak to you about a topic that close to both my technical experience and future vision. AI-driven integration revolutionizing data management in multi-cloud enterprise environments. In today's session, I would walk you how AI-powered integration frameworks can transform enterprise operation by eliminating the complexity of working across multiple cloud platforms like AWS, Azure, GCP, improving visibility, performance, and security, and delivering measurable ROI while ensuring organizations stay fully compliant with evolving regular standards. Whether you are in financial service, healthcare, or technology, the strategies and techniques we'll explore today are designed to help you modernize your data infrastructure, reduce operational overhead, and gain a competitive edge in a rapidly evolving digital world. Let's get started. So the slide, multi-cloud reality, the integration challenge. Let's start with the reality we face today. Most enterprises don't operate in a single cloud environment anymore. They are using AWS for scalability, Azure for enterprise integration, and GCP for AI services simultaneously. But with this flexibility comes complexity. We encounter four main challenges. First one is fragmented data. And enterprises move to the cloud. Many adopt of multi-cloud strategies, leveraging AWS for scalability, Azure for enterprise integration, and GCP for AI services. While these hybrid approaches provide flexibility, it also data ecosystems it not helping much more. So what happened in practice is customer records might be stored in AWS S3. For example, applications logs are logged and indexed in Azure Monitor, and analytic data text resides in Google Cloud BigQuery. These environments don't talk to each other natively. Each uses different formats, different APIs. And next one, security vulnerability. Each cloud has different policies and protocols. This inconsistency introduces gaps between technology and also let us tell one example. Let us now address one of the most pressing issues in any multi-cloud architecture: security vulnerability caused by inconsistent policy enforcement across cloud providers. While each cloud be in AWS, Microsoft Azure or Google Cloud Platform GCP offer strong native secure controls. They are fundamentally different in design, configuration, and operation. This lack of standardization introduces significantly risk when organizations attempt to unify them under one architecture. What causes these vulnerabilities? Different security models. Each cloud provider has its own IAM, Identity Access Management. AWS uses IAM roles and policies, and Azure uses role-based access control. GCP relies on IAM bindings and roles tied to resources hierarchies. These models are not interoperable, and even small misconfigurations like over permission roles or inconsistent MFA policies can become entry point for attackers. Operational inefficiency. Integration is often manual error, resources heavy and time consuming. Let's now examine a critical barrier to enterprise agility and perform in multi-cloud environments. Operational inefficiency caused by manual integration. While the term may sound procedural, it impacts in strategic affecting productivity, scalability, and business continuity. So, what is the manual integration? Manual integration refers to the non-automatic human-driven process of connecting services, transferring data, and aligning workflow between cloud platform like AWS, Azure, and GCP. Compliance complexity. So, for example, meeting HIPAA, Health Insurance Portability and Accountability Act, or SOX compliance in a multi-cloud setup requires deep expertise and constant monitoring. Having discussion the operational security and data challenging in multi-cloud ecosystem, let's now turn to a domain that is equally critical compliance. But when your data and workloads are spread across AWS, Azure, and Google Cloud, compliance becomes exponentially more complex. So why complex compliance is so challenging in multi-cloud? One is different regions, different rules. Each cloud provider stores data in multiple regions by default. If you don't configure storage correctly, your data might land in incorrect path where striker rules apply and you may not even know it. For example, I will take a HIPAA, Health Insurance Portability and Accountability Act, mandates end-to-end encryption and strict access control for healthcare data. One misconfiguration can lead to regular breach and serve financial penalties. And inconsistent audit trails, each cloud logs and tracks eventually differently. AWS uses Cloud Trail, Azure has monitor and log analytics, GCP has cloud audit logs. Without integration, these logs become disjoint, making it extremely difficult to perform unified audits, responses to incidents, or prove compliance during external assessments. Evolving regulations. So regulator requirements changes frequently, keeping up with updates across multiple compliance while aligning with multiple cloud provided configurations require constant manual efforts and specialized knowledge. This is not just a legal risk, it's an operational drain. We'll go to next slide. AI transformation, automation integration. AI transformation, automated data mapping. Let's now talk about how AI transforms integration, starting with one of the most powerful feature, automated data mapping. In a multi-cloud setup, data exists in many formats, structures, and locations spread across platforms like AWS, Azure, and GCP. Traditionally, connecting this data requires manual mapping, understanding source and target fields, writing transformation logic, ensuring data types and format align. This process is time consuming, prone to human error, and needs constant updates whenever a schema changes. So, what does AI do differently? So, with automated data mapping, we use advanced machine learning algorithm that can scan and understand data sets even if they come from completely different systems. Automatically detects relationship between fields. For example, it can recognize that customer ID in AWS matches to Azure customer number. If it don't matches, it will cause the issue. Generally, accurate mapping logic without requiring manual intervention. The results are impressive by using AI. For this task, we have seen 85% reduction in manual data mapping efforts, significantly improved accuracy, especially in large-scale environments with thousands of fields, schemas. So, faster integration, timelines, and fewer errors in production, and intelligent data routing. So next, let's how transform that where data moves across multi-cloud environments with a concept called intelligent data routing. In traditional systems, data flow are typically static. Once you define a route from one cloud service to another, it remains fixed regardless of change in network traffic, latency, system performance. But in dynamic multi-cloud environments like AWS, Azure, and GCP, network conditions can change every second, and a fixed route can easily become a slow or overloaded path, reducing performance. So, what is intelligent data routing? So, with AI powered routing, the system is no longer passive or active learning and optimizing in real time. Here, what it is analyzing network traffic conditions continuously, such as bandwidth, availability, latency, and server loads. Chooses the fastest, most efficient path for data to travel every time as a request is made. Adapts instant if something changes like traffic spike, system slowdown. This enterprise that your data reaches its destination faster, avoids bottleneck, and maintain consistent performance across all cloud platforms in real world. We see significant reduction in latency, improve throughput for high volume data applications, and much better system reliability, especially during peak traffic. And next, governance enforcement. The final piece of AI driven integration I would like to highlight is governance enforcement. A major leap forward is managing compliance across multi cloud environments. Now, let's be honest, governance and compliance are often seen as complex, time consuming, and constantly changing. Every organization must follow industry regulations like GDPR, HIPAA, or SOX, depending on your sector. But when you're working across multiple cloud platforms, AWS, Azure, or GCP, keeping policies consistent become extremely difficult. Each platform has different tools, different permission structures, different update cycles. So manually monitoring is not only slow, it is also risky. So what does AI do for governance? This is where AI powered policies engines make a huge difference. These engines are self-learning, meaning they monitor evolving regulations and automatically apply the latest rule. They enforce compliance consistently across all cloud platforms, no matter how complex your setup is. Companies reduces their compliance monitoring workload by up to 70%. Real-time visibility across cloud ecosystem. So issue detection, early problem identification with AI. Now let's talk about one of the most powerful outcome of AI-driven integration, early problem detection. In complex multi-cloud environments, issue can arise at any time. A failed data transfer, a slowdown in response time, or even silent security misalignments. So traditionally, these problems are only discovered after they cause visible damage like an outage, missing SLA, or compliance violations. So AI helps. AI changes the game by acting as 24 by 7 intelligent monitoring systems. So here what it does, it constantly scans logs, data flow, and system behavior across all cloud platforms. It uses patterns recognition and detection to spot irregularities often before humans can notice them. It can even predict potential failures by learning from past system behavior. This proactive capabilities led to a 94% improvement in early issues detection. So, resolution time, faster troubleshooting with AI, following on for early detection. Let's talk about what happened next resolving the issue. With traditional systems, even when a problem is detected, finding the root cause can take hours or even days. Teams must manually check logs, trace dependencies across cloud services, and coordinate between multiple platforms like AWS, Azure, and GCP. This is slow, frustrating, and costly. How AI speeds up troubleshooting with AI-driven monitoring and diagnostics. The story is very different. AI helps reduces troubleshooting time by 76%, automate root cause analysis. AI quickly pinpoints the source of problem, whether it is misconfigured permissions, a failing service, or drop network packets, correlated log insights. It analyzes logs across all cloud simultaneously, identifying patterns and dependencies in seconds. Smart recommendations based on the historical data, AI can suggest the most effective resolution steps, reducing guesswork and back and forth. And operational efficiency, boosting IT team productivity with AI. Let's now look at one of the most exciting outcomes of AI-driven integration is 3.5x increase in operational efficiency. That means IT teams are getting more than three times the work with resources and less manual effort. In a traditional setup, your IT team is constantly switching between cloud dashboard, writing scripts, troubleshooting errors, managing integrations, and trying to make sense of scattered data. It's not just exhausting, it's inefficient. So AI boosts efficiency with AI-powered unified monitoring platforms. Your team no longer have to chase problems across systems. Instead, the benefit from single pane of glass visibilities across AWS, Azure, and GCP. Maybe you can use single dashboard. No more jumping between dashboards. Everything is integrated into a one intelligent interface. Automatic alert systems in place, and AI doesn't just tell that something is wrong in tell what, where, and how to fix it. And going next slide. Implementation framework. The assessment phase. Let's now talk about how we begin implementing AI-driven integration across a multi-cloud environments. The first and most important steps in the assessment phase. This is where we lay the foundation for success by thoroughly understanding the current environment, aligning it with the business goals, and identifying where AI can make the biggest impact. So the step one, current state analysis. The first thing we do is map out your existing cloud infrastructure. We identify which services are running on AWS, Azure, and GCP based on the cloud technology, where there are performance gaps, redundant process, or security vulnerabilities. This gives us clear picture of the baseline, what's working, what not, and where we can improve. Think of it as performing a health checks for your multi-cloud architecture. And step two, business requirement mapping. So next we align the technical side with the business goals. What outcomes are you trying to achieve? Is it faster data access, cloud costs, or strong compliance? When then define clear key performance indicators and return on investments metrics to measure the success of integration initiatives. This ensures that the solution is not just technical sound but business driven. And step three, finally, we look at how data flows across your cloud platform. How much data are you moving? How fast that is needs to travel? How complex are the transformation? This help us identifying high impact integrations opportunities, places where AI can boost speed, reduces errors, and improve efficiency. The most it also helps prioritize what to integrate first for maximum business values. So I'm going to next slide. Strategic platform selection. Choose the right foundation for integration. Once we complete the assessment phase, the next key step is implementing AI-driven integration is choosing the right platform. This is what we call strategic platform selections. Not all platforms are created equal, and the wrong choice can lead to lock-in, poor performance, and endless customization. So we focus on four critical factors that defines further ready integration platforms. The first one is interoperability. First, we look at multi-cloud world. Your integration platform must work seamless with different cloud APIs, various data formats, and multiple communication protocols. This means you should be able to connect AWS, Azure, GCP, and even on-prem systems without writing custom code for each connection. Think of it like a universal translator that allows all your cloud services to talk to each other smoothly and instantly. Data is AI capabilities. We want a platform that comes with built-in machine learning tool for predictive integration like spotting potential failures before they happen, pattern recognize across data sets, and autonomous optimization of workflow so the system keeps improving itself over time. This isn't just about automation, it's about intelligent automation. And next we'll go scalability, then come scalability. As your business grows, so the volume of data, the number of users, and the complexity of your cloud services, your integration platform must handle this growth without slowing down your business a requirement a full architecture. It should adapt dynamically as your environment evolves. Think like choosing a bridge that not only handle today traffic but is ready for tomorrow rush hours. And next, vendor independence. Finally, we took for vendor independence. Your integration solution should have flexible architecture that doesn't tie you one cloud to other cloud. This ensure portability of workloads, easier migrations or expansions, and better dealing with the cloud vendors. I will go with next slide. Performance optimization techniques, making multi-cloud run smarter and faster. Once the right integration platform is in place, the next step is performing optimization, making the next step multi-cloud environments not only works but work faster, efficiently, and intelligently. AI plays a major role here. We use a combination of smart technologies to boost systems performance by 40 to 60%, and I would like to walk through the four key techniques we use. The first one is predictive resources allocation. The first technique is predictive resources allocation. So in this technique, AI constantly analyzes system usage and forecast upcoming demand, whether it's a storage, compute, or bandwidth. Based on its automatically scales resources up or down in real time. This means you avoid performance bottleneck during peak traffic and you also save cost during quiet period but not over allocating. Next is intelligent data filtering. Instead of transferring and processing all data, it determines what relevant and filter out unnecessary information before it moves between systems. This reduces network traffic storage usage and data processing loads. Think if going through your inbox and only keeping the important emails automatically. And next one is then we integrated edge computing. This means the data is processed close to its source at the edge of the network rather than sending everything back to the cloud. Benefits like faster response times, reduces latency, and improve performance for real-time applications like retail transactions. And finally, we use adaptive comprehensive compressions. AI dynamically compress data based on the content, network conditions based on the network conditions, and priority level. This ensures faster transfer, especially across regions or providers, and helps optimize bandwidth usage. You get faster performance with less traffic without compromising on data. Going to next slide. Case study. Financial services transformation. Let's look at a real world example. With AI powered integration in place, the transformation was dramatic. Integration time dropped by 87% when took weeks now took just days or even hours, thanks to automated data mapping and intelligent routing. Data error reduces by 86%. AI identified and corrected inconsistencies in real time, leading to clean and more reliable data. Complaints cost fell sharply. Self-learning policies engines ensure that all systems stayed aligned with the regulations, reducing manual effort and audit-related stress. System uptime improved significantly with predictive monitoring and intelligent troubleshooting. Outages become rare and recover was much faster. I will go with next slide. Emerging technologies reshaping integration. As we look to the future, it is clear that AI-driven integration is just the beginning. A new wave of emerging technologies is reshaping how we manage data systems and security across the cloud, and it's happened faster than ever. Let me briefly walk you four powerful technologies that are revolutionary the next generation of integration. The first one is autonomous operations. First, we have autonomous operations, what we often call self-healing system. Imagine a system that detects an error on its own, identifies the root cause, and fixes the issue automatically without waiting for human interventions. This system uses AI to monitor operational in real time, learn from past incidents, and adapt continuously. It's like having an IT team that never sleeps, never makes mistakes, and resolution problems before users even notice. And next one, second, we have edge computing, a powerful approach where data is processed at or near the source instead of central cloud system. This is especially useful for smart retail, real-time monitoring in healthcare or manufacturing. Next is blockchain security. In multi-cloud and hybrid environments, trust and auditable are critical. Blockchain provides immutable audit trails records that can be changed or erased across cloud providers. This creates cross-platform trust for transactions and access, better compliance, tracking, and stronger protections against data tampering, and manipulating. It brings transparency and integration to data workflow, no matter where the data lives. And finally, we have cognitive integration, a concept that brings natural language understanding to cloud operations. Imagine your voice commands are plain English into managed cloud services. For example, show me all fail integrations for this morning, or secure all healthcare data with GDPR level encryption. This makes cloud management more accessible and user friendly even for non technical stakeholders. Go to next slide. Implementation roadmap, a phase path of AI driven integration. Now that we explored the strategy, technologies, and benefits of AI powered integration, the next big question is how do we put it all into actions? We follow a structured phase roadmap that ensures that transitions to AI driven integration is smooth, measurable, and aligned with business priorities. Let me break down each phase of implementation roadmap. So the phase one, discovery, 4 to 6 weeks. In this first phase, we took time to fully understand the current environment. We access your existing cloud infrastructure, review integration points, identify pain points, security gaps, and inefficiencies, and define clear business and technical requirements. This phase gives us foundation for smart decision making. And phase two, foundation 8 to 10 weeks. So once we define the need, we move to foundation phase. Here we deploy the core integration platform, connect your primary systems, whether AWS, Azure, GCP, or on-prem, and establish basic data flow and monitoring. This step is all about getting the system talking to each other in stable, scalable way. And phase three, AI enhancement, 6 to 8 weeks. Now we bring into real power AI automation. In this phase, we implement automated data mapping, enabling intelligent data routing, set up self-learning policies enforcement, and configure predictive monitoring. This is where we start seeing significant performance gains and reduce errors and faster operations. Your system becomes smarter and more proactive. And final phase four, optimizing ongoing. And finally, the journey doesn't stop with the implementation. We move into a continuous optimization phase where we monitor performance metrics, analyze system behavior, and fine-tune integration platform for even better results over time. This ensures the system grow with your business, adapts to change, and keeps improving. Going to next slide. Key takeaways. So transforming your multi-cloud strategy with AI. As we come to close of the session, let's take a moment to recap the takeaway, the core message that can help transform your multi-cloud strategy using AI. These aren't just technical points, they are strategic shifts that can help your business move faster, smarter, and more confidence in the cloud. AI eliminates integration complexity. The first takeaway is simple but powerful. AI dramatically simplifies integration through automated data mapping and intelligent routing. You can reduce manual effort by 85%. Unified visibility drives performance. Visibility is performance. With AI-powered monitoring is in place, you can detect 94% of issues before they have an impact. And strategic platform selection prevents lock-in by focusing on interoperability, AI capabilities, and vendor independencies. You will prevent vendor lock-in and set your business up for long-run flexibility. It ensures that your cloud strategy is not just effective but also future reference and measurable ROI across industries. And finally, the real business results we see in organizations in financial services, healthcare, and retail achieve 40 to 60% efficiency gains through AI-driven integration. This isn't theory, it's happening now across industries and across the world. And next slide. Thank you all for your time and attention today. It's been an honor to share insights how AI is transforming multi-cloud integration, not just as a technology upgrade, but as strategic enable for performance, compliance, and innovation. I hope this session has helped you see what possible when we bring intelligent automates and visibility into complex cloud environment. Thank you all for your time.